Hi there. I thought I would compare the 991EX with its own worst enemy, the 991EX fake version. As many of you probably already know, if you go shopping for a 991EX, you're met with quite a minefield in terms of shopping. You can get a second-hand one for a few pounds, it's probably a fake. You can get a second-hand one for 10, 15, 20 quid, and it's probably a fake. And you can get ones that sell for 80 quid or so, and they claim to be genuine, and everything in between. These are the calculators. Here's an authentic one next to a fake one. Difficult to tell them apart. You know, you might say that, you know, one of the keys, the printing's a little bit wobbly on it. Very difficult to tell on a listing. Backs of them look pretty similar. The cases are quite funny because I now can't tell which one is which. They've both got these sorts of cracks here. So they've both cracked in the same place, and they both have this kind of shell-like texture. It's quite nice actually, but yeah, trying to work out which one's which is tricky. So sorry, we're running out of light, so I will try to be quick. But this one here is the fake one, this is the genuine one. Yeah, once you've got it, it's fairly easy to figure out whether it's fake or not. Just have a little Google for that. I'm not going to go into it here. Right, let's have a look then. So why don't we have a look at the UI first? So the EX series has got some particular unique UI elements. So one of them is 1 divided by 2 to the power of 3, 1 over 2000. 1 divided by 2 to the power of 3. Let's try and do that properly. Okay. Basically, it does that in the same way, exactly the same as the ES Plus, but not like the CW or the CW Plus, which will add brackets around it or just calculate it differently. Order of operations, 1 divided by 2A. It does exactly the same. It puts brackets around after the division, which is not something that used to happen on the ES. Yeah, you just get the 2A there rather than the brackets added around it. The MS would do something funny with storing. So I'll just show this. If you do 4 equals times 4, so you've got answer times 4 in there, 16, store it into A, and it will store 16. The MS series actually does that a bit differently. Okay, in terms of the menu, they look identical. It does feel slower on the fake one, so you can move around really quickly on the genuine one, pretty slow on the fake. I think the processor must be a lot slower on the fake, and we'll see that later. Okay, what about accuracy? Because that's probably one of the most important things. UI wise, it's pretty much exactly the same. Accuracy, one of the most useful tests for accuracy, or one of the most famous one, is this sine, cosine, tan, and then all the inverses of 9 in degrees, and we've got that there. Now, gives a different result, so that's one way you can tell apart these two calculators. In actual fact, this is returning 15 digits of decimal precision. The fake one returns 16, and as such it actually returns a slightly more accurate result for this. So it gets a score of 9.7, which is nearly 10 digits of accuracy, and this one gets 9.1. Not much of a difference. I did try a bunch of borderline trigonometry cases. I'm not sure there's that much to write home about. So, for example, We did the tan of 1.570796 on both of them. The fake actually got one extra digit of precision, 4.8 versus 3.2. Cosine to the -1 of 0.999999999. This one actually got 15 digits precision versus 10 on this one, so it swings and roundabouts. In terms of the limits of what you can put in, the genuine one will not allow you to put in 10 to the power of 10 and take the sign of that, whereas the fake one will allow you to do that, but it won't allow you to put in 10 to the power of 20. So kind of swings and roundabouts in terms of accuracy. This one does have one extra digit of precision, so you know, it doesn't always make use of it though. Okay, so what about advanced functionality? I compared complex numbers between the two of these devices. They are very, very similar. So they can add complex numbers, multiply them. You can take them to the power of whole numbers, I think at least square them, or to the power of 4, to the power of -1. You can't take them to the power of fractional powers. You also can't take numbers to the power of a complex number, and you can't do trig or transcendental functions. So you can't take ln of -1, for example, or the natural logarithm of -1. That doesn't work on either of these. So they're both fairly limited, but they're both the same, basically, identical, pretty much. Integration is quite interesting. I've got a series of tricky integrals that I've collected from elsewhere on the internet. I won't go into them, but I can give you a link for that. Sorry, it's getting a bit dark here. The first one, we got 1 over the square root of x between 1 and 2. The fake one gets slightly less good result on that one compared to the genuine. E to the power -x squared between -1 and 3. The fake one actually gets one more digit of precision. The absolute value of x squared minus 3x between -15 and 15. This is one that's done the rounds on the internet a bit. The genuine EX gets this one wrong. It misses the absolute portion. The fake one gets a pretty good result, 4.4 score, so about just over 4 decimal places. This one, the tan between 0.0 and 1.57079. The fake one can't do it, it just times out. So after 10 minutes, the fake one seems to give up. The genuine one can get a good result on that. Tetration, this one's kind of interesting. So if you take the integral of x to the power of x to the power of x between 0 and 1, it just comes up with error on the genuine one, whereas on the what have I done? Okay. I picked up, just shows how easy it is to get them muddled up. I picked up the wrong one and did a typo on this one. So right, so this is the genuine one here, and it's come up with a maths error, whereas the fake one can calculate it. And if you do say 0.01 instead of 0, the genuine one will be able to return a result there. So that's kind of interesting. Another interesting difference is you can solve for the limits of an integral. So if we do x squared and we go between 0 and x, I know that maybe doesn't make that much sense, and maybe you shouldn't be able to do this. Oops, that's not what I meant to do. Go back. Oh, don't do that. Alright, what have I set off here? Okay, let's hope that one just sorts itself out. shift, I wanted the equal sign, that's it, 8/3. Okay, let's do that, 8/3, and then solve that. Fake one gives you a syntax error, whereas this one will solve the limit as 2 there. Did I mention the display? The displays are identical, like pixel for pixel, and all the gubbins along the top are the same. Okay, one of the ones that's been picked out as being a real problem on the Fake is probability. So for the binomial distribution, there's a good example of that, and it's not accurate. I think I gave it an accuracy score of 1.3, so barely over 1 digit, whereas the genuine 991EX got 8.5. Matrix, I haven't tested much of the functionality, but both of them will do 4x4 matrices, and I haven't done much more of that. Okay, so overall, I thought the genuine EX would completely thrash the fake one, but that is really not the case. No calculator is perfect. Every calculator will have a bug or a deficiency of some sort, but the fake EX has got one more digit of precision. It can certainly solve some of the integrals that the EX can't, and it may even be better in some ways. I think if it took off this sort of 10-minute time limit, it probably would get a lot of integrals correct that the regular Casio doesn't. And it, for some trig functions, it was returning more accurate results. But on the other hand, for some integrals and for some trigs, it was returning slightly less accurate results. So it was here and there, really. It definitely feels slower. It feels more sluggish. But I think the biggest issue with the fake is that it's a fake. So it says it's a Casio fx-991EX, and it isn't. If it was just its own calculator, in some ways it might be better, because, if it was named something completely different, then you would be able to identify and you could recommend it to your friends or something like that. Whereas I don't know how many fakes are out there. This is just one that I picked up. How could I guarantee picking up one of these again? And the other thing is I haven't done a completely thorough testing of this. If I had an exam that relied on something being correct, I don't think I would use a fake one. Because even though this one isn't going to be, the genuine one isn't going to be perfect, that that if you were to do some big national exam and it relied on this calculator to get something right and it got it wrong, I think that's something that probably hit the news, and they'll probably just discount that question, because so many people use this calculator or something similar to it. Whereas if this one got something wrong, well, that's just tough luck. Doesn't seem fair, but I understand why. So yeah, overall the fake is not as bad as I thought it would be. In some ways it may even be better, in some ways it's a little bit worse, but the problem is it's still a fake, and that means it's going to be hard to build up any trust for it. So yeah, I don't really recommend taking any important exams using a fake one. And that's it. Thank you very much.